diameters there is to break up the RPM so that you don't gall any of the surfaces.
Now that's an intriguing idea.
This is machining some of the sleeve work, putting the holes in the sleeve at the proper place, the proper depth, to line up with the porting in the jug. This is one of the first assemblies where I was bringing the engine together, the complete engine for the first time, to see all the parts match.
How'd you do your drawings?
The drawings were done by a friend of mine who took the dimensions and put them in a computer. The original drawings that I based the engine design on was I took the 400 cubic inch engine drawing and I just kept enlarging them until the internal dimensions equaled 30 cubic inch. And I believe it was 105% or 115% from the book. And that means that there's a 3 1/4 inch diameter piston and a 2 1/8 inch stroke on this particular model. It should have been a 2 1/4 inch stroke, but it's only a 2 1/8 inch stroke. I misread some of the numbers. A little less power. This is some of the machine work in the computer that the girl had done for me. She was very nice in putting all the numbers in there. And this is just the basic one line. If you go into it in the program and you want to read it out, it'll put all the dimensions on there, every single one of them.
Sounds like AutoCAD.
I believe it's a more professional model from AutoCAD. It's a true three-dimensional, and right now it's a two-dimensional rendering. Okay, so more of the assembly.
Is there something about a Bourke engine that attracts flies?
No, it's just probably me. This is the intake manifold before it was finished off. Mounting the carburetor. The choice of a carburetor was for a Solex, the similar one that ran the Volkswagen engine, of approximately twice the cubic inch of this one. Therefore, I thought it would, since it was feeding twice as much, only half the time, it would be equal to it. In the starting cart the first time, hand cranked, wouldn't work. Motorcycle starter, not enough power. And finally we put a Volkswagen flywheel and starter assembly outside, and that worked rather well. Except I didn't like the open end of the flywheel hanging out there and where people could get their fingers into it and all. And later on I wanted to put it on a Volkswagen engine anyway, so I decided to cut a bell housing off, and that's in the present configuration.
Okay, now your colleague's name again?
Mac Burns.
B-Y or B-U?
B-U-R-N-S. He's a very nice gentleman that has been very generous with his time and machinery and skill. Shaft. And the particular way, it doesn't quite show it in here, but the particular way he put the counter throws onto the crank was very unique. The crank itself was machined with round curves going up to the throw so that you could slide the triple slipper bearing up and over and the Scotch yoke cage around and bolt together. And then you put the counterweights on with a bolt going through the counterweight to hold it in place. And I didn't know this until after I had made mine.
Well, see the next one.
And this one, like I said, has got the old roller bearings in it, and he invented the new slipper bearings, so I went with slipper bearings on mine because I could not find a roller bearing that would go with the RPMs and the horsepower and the size that I wanted for this engine.
Okay, now the slipper bearings, each layer is made of a different material?
They're alternate layers.